Hold on. And I'm live.
As a reminder, if you are in Miss Stella's or Mr. Stocko's third period class, please report to the auditorium at this time. If you are third period,
Stella Stofko.
please report to the
Auditorium at this time. Thank you. So, so Stafford Stafford and Southern are going virtual leading up to the end of December. But then Stafford and Southern are going back to school on January 4th. Someone explain to me how that makes sense. I don't know. LBI schools, on the other hand, they are going virtual for the last week, right before Christmas. They're going to be going virtual for these 3 days, and LBI schools will be going virtual for the 1 week after Christmas break. That makes a bit more sense. Just saying. As for us, here we are. We're all here. Will that change? I don't know. The next Cali score update is supposed to be coming out on Thursday. Obviously, the numbers have been going up. Will they go up enough? I don't think so. I think that we'll be stuck with a Cali score of 3. And we will continue going to school until enough people complain. Why aren't your parents complaining enough? That's a good explanation. But anyway, now, in terms of inclement weather, I'm sure, all high school students turn into meteorologists at the first sight of snow. Yeah. You do know that even if we do have a snow day on Thursday, I'm still been given the green light to teach, right? Yeah, I'm so excited. So even if you're at home, I want you tuning into Google Classroom on Thursday because I will still be doing stuff. Now, will I actually be going live and teaching a lesson? Maybe, if I feel like it. I have the ability to do that outside of this dumb Chromebook because I have better streaming equipment at home. I think it'll be fun. Anyway, I'm just giving you the heads up on that. Now, in terms of what we are doing, obviously, this week I have you Tuesday, Thursday, and then next week I have you Monday, Wednesday. What are we doing Monday? Ooh. We're doing benchmarks. Monday and Tuesday are deemed to be benchmark days, in which you'll be taking the benchmark in this classroom on Monday. Ms. Markey, what's the point of taking the benchmark? Well, my supervisor likes to see that you guys are, performing well over the course of time and that you're learning more and you're growing in terms of your knowledge and scores. Mr. Markey, is the benchmark going to be on stuff? Whoa, y'all see that? Well, you can go home. He didn't pay attention yet. That we haven't learned yet. Well, that's kind of the point of benchmarks, isn't it? We give it to you in the beginning of the year on stuff you don't know. And then over the course of the year, you actually learn the information so that when you take the benchmark later on, you actually score better. It's almost like it's purposely designed that way in order to make people look good. Isn't that amazing? I know. It's not my call. It doesn't make me look good. Someone actually asked me, Mr. Markey, does it reflect positively upon you? And I was like, it doesn't reflect anything on me. It reflects upon my supervisor. So I just want you guys to do the best that you can. Ooh, who's there? There he is. Sorry. People talking in the chat. So what's going on at the end of this week? I don't have you on Friday, but what's going on at the end of this week? My last announcement. Progress reports. I know. I want you to think about this. What's today's date? 15th. You are approximately 3/8 done with your school year. Think about that. Yeah. 37.5%. Yeah. It goes by fast. Before you know it, it'll be midterms. Midterms are coming up the week of the 21st. We began an introduction to Chapter 6, talking about exponent properties. Today, we're going to put those exponent properties to work, and we are going to practice some things. And I'm going to introduce to you something that you may never have seen before. In elementary school, did they introduce to you addition and subtraction and multiplication and division? Did they ever introduce to you the fifth operation? What does it do? Oh, there is a fifth operation. There is. I'm going to teach it to you today. So, if you would, ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Oh, yes. You got it. Okay, I got you. I know it's a little tough sometimes to type mathematical equations. Yeah, you know. But like I know what to do. I got you. Ooh, a missed call. Nope, and I got 2 voicemails now. Great. Let's look up. Let's see. Oh, nothing but rain. I don't know. Hold on, let's go. Today's Tuesday, right? Let's go hourly. If you go hourly, it looks like rain, showers, wind, rain. Thursday, rain, rain, rain. 8 a.m. looks like some snow showers, but they don't look like it's going to be enough. Aw, sad days for all of you. Huh? To the nurse. Here, give me a second. Let me write out this title. And then I can write out a pass. Actually, here, you fill out the beginnings of the pass so I can write out this title. Today is the 15th. Oh. Yeah. There we go. Cool. And I am going to call this function operations. And I'll give you various examples as to what I'm referring to. So right now, I am going to define an f of x and a g of x. The f of x that I am going to give you is going to be, oh, what's up? Ah, come on. Here we go. Oh, right, to the nurse. That's right. I was about to check restroom, but I made a mistake. All right, cool. The f of x that I am going to give you is going to be 2x squared. And the g of x that I am going to give you is going to be x plus 1. Yes, we'll start with something like that. And then I have other examples that are going to take this a bit farther. Now, the exponent properties that we learned in the previous class period, or that we hopefully relearned or refreshed ourselves upon, are going to come into play with what we're doing with these two functions. You've been dealing with function operations for a long time. F of x, g of x, plugging numbers in, whatever. But there may come a time where then I ask you to do something along the lines of, well, find f of x plus g of x. Immediately, you're just like, what the crap is this? I want you to add those two functions together. I don't know how to add those two functions together. Like terms. You've heard that phrase before, right? Yeah, combine like terms. Yeah, okay. Well, if I have to take f of x and I have to add g of x, well, there aren't any like terms. So do I just do this? Because, like, look, none of them are like terms. I literally, here's the f of x, and I add the g of x. I could try to combine, like, yeah, that's it. You're done. There's the problem. Oh, where's the trick? There's no trick. It's literally you just add them together. Okay. Cool. Just for the sake of argument, another way that you might see this notation it might look like this. This is the same notation, just so we're all on the same page. You could add f of x and g of x separately, but then if you ever see this notation where f and g are in the same set of parentheses, it's telling you to do the same exact thing. Yay. Seems straightforward. Yeah, it kind of does. It kind of seems straightforward enough. Let's take it a little farther. I could then ask you with the exact same two functions, I could ask you to find f of x minus g of x. Now, the order in which you do this stuff does make a difference. You do have to pay attention to the order in which things are being subtracted. We are subtracting g of x. We are subtracting all of g of x. Meaning, yes, we are subtracting the x plus 1, which in reality looks something like this. 2x squared minus x plus 1. Notice, what did I put around the x plus 1? Why? Why does that make a difference? Ooh. What does this mean for our problem? How do I actually continue doing this problem? Let me write down what it actually looks like, and then you have to tell me what the heck it is that I just did. Yes, you are. You have to distribute that negative. That is being added or subtracted in the middle, the x plus 1, means that the negative go to both of them. But yeah, that's what that thing would be. There are all sorts of little tiny rules and nuggets of information that are going to mess you up along the way. And I'm going to hopefully help you find those landmines so you don't step on them. But we'll get there. Now, just for the sake of argument again, f of x minus g of x might also be written like this. It might also be written like this. So again, I just want you to see that, write that down. Make sure that you don't panic when you see something like this, because it's literally just telling you to do what we just did, where you just have to subtract the two functions from each other. All right. The third operation, multiplication. Pretty straightforward. I might say, okay, what's f of x times g of x? Well, f of x was 2x. I can distribute that. I am allowed to distribute that. I'm going to tell that. I totally can. That would give me 2x cubed plus 2x squared. That would give me 2x cubed plus 2x squared because, well, x squared times x to the first power. You add the exponents together. Cool. And I get something like that. Again, fairly straightforward. Multiplying this junk together. In reality, a lot of the stuff that we're going to do is going to come down to what practice we can get done. But once again, here's the notation. F times g of x. I'm kind of slowly at this moment. Someone get the door? I'm slowly at this moment walking through just the basic operations. Adding, subtracting, multiplying, and yes, I will talk about dividing in just one moment. Operation. Here, take these temporarily. I'll put those back. Then here's the fourth one. F of x divided by g of x. Where it is quite literally, well, f of x was 2x squared divided by x plus 1. Now, there are going to be instances in which you can and cannot simplify this stuff. Let me repeat that. There are going to be instances in which you can and cannot simplify the division function. This is one of those instances in which you can't. And simply put, that is the answer. That is literally all that you have to do for this problem when you have to divide those two functions. It seems strange. It seems like, are we cheating? Like, math is supposed to be more complicated than this? Well, that's literally just it. And again, one more time to clarify, f of x divided by g of x, you may see it written like this. You may see it written like that, f divided by g of x. It's the same exact concept. They just want you to divide those two things out. I have some sample problems that we are going to do in a little bit. I have some sample problems. Actually, you know what? I want to do those sample problems now. Yes, I've decided I want to do those sample problems now before we move on. So we get the practice with just the 4 operations that I'm going to be dealing with here. And then I want to review that information to make sure that we are all on the same page with it. So yeah, the 4 basic operations. Here's what I'm going to do. I am going to go to Google Classroom, and I am going to add in a worksheet directly into, there we go, that one, directly into the Google Stream. PDF for today. Post. Bong. So what I'm going to suggest to you is this. I am going to put these problems up on the board in a minute. But if you prefer to see the problems a little bit more clearly, copy of this PDF, this one right here. And the problems that I am focused on, the problems that I would like my attention to be turned to, let me actually open these up directly in the PDF form. Nope, not that one. Oh, there it is, right there. Boom. Yes. The problems that I would like to focus on are numbers 1, 2, and 3 on this particular worksheet. There you go. For number 1, they are simply asking for you to take these two functions, add them, subtract them, multiply them, and divide them. And they want an answer. They want a simplified answer. Now, simplifying is going to be the trickier part. For number 2, same thing. They want you to take these two functions, and they want you to add them. They want you to subtract them. They want you to multiply them, and they want you to divide them. And the same thing for number 3. Now, number 3 is going to be a little trickier because obviously there's some factoring that's going on there. But again, they want you to subtract them. They want you to multiply them. They want you to divide them. So like I said, if you want to pop open those Chromebooks to take a look at the PDF a bit closer, because it may be easier to see, I threw this PDF into the Google Classroom. If you prefer just looking at what I have on the board, I'm just going to zoom in right here on the first 2 problems so you could see them a bit easier. The third one you might not be able to see as well if I didn't zoom in. So let's just focus on at least the first 2. So I'm going to give you guys the next 5 minutes or less. 5 minutes. And I would like you to knock out numbers 1, 2, and 3. So like I said, if you need to see them on the PDF, it's in the Google Stream. Otherwise, you have the problems on the board, or at least the first 2. Let's get moving. the sake of argument, I am going to scroll over because at this point, hopefully, if you were using the board, you saw that first problem. I'm just scrolling over so you could at least see the third problem as well. So you missed the class, right? So it was you. Yes. You, me, Alyssa, and Cameron missed the class. So it's just the four of us. Yes. And now you're facing me. If you lose to me, and then lose next the following week, you still win still. Just saying. All of us are still winning. Okay. For the record, that was about fantasy football. We have a consolation bracket tournament for people who don't make the playoffs. And if you end up being in the losing championship game, you win what is known as the Scody Championship. Miss Scody knows that it's named after her. She's actually honored that it's named after her. It's for our last place finisher. She was once in our fantasy league and she lost like 20 straight games over 2 seasons. Pretty funny. She never said her lineup. Okay. For the sake of time, and to show you how straightforward some of these problems are, just some. Now, what's going to happen is that for some of these problems, they are going to redefine what it means to be f of x and g of x for the problem. So for this first problem, they're telling you that f of x is 2x plus 1. And they're telling you that g of x is equal to x minus 3. And simply put, they want you to perform the 4 major operations on them. Operation number 1, they want you to add them together. Well, f plus g of x, if I were just to combine like terms, should give me 3x minus 2. Combining like terms, well, I got a 2x and a 1x, which add up to 3x. And I got a 1 and I got a negative 3, which add up to negative 2. Simply put, that's all that you have to do for that particular problem. Cool. But I still have other operations to get done. They want me now to do f minus g of x, to subtract those two. Now, subtracting them does take a little bit more because you have to. So I'm going to be doing a 2x plus 1 minus x. Now, watch very closely. Plus 3. Now, I'm not done yet. I do not have the correct answer just yet. But in terms of combining, in terms of subtracting the x minus 3, I have to realize that I would be distributing a minus sign to both of them. This should give me a 1x plus 4 as that final answer. Then they want me to multiply these two things together. F times g of x, which I would be doing 2x plus 1 times x minus 3. So again, parentheses. If you prefer foil, you could do foil on this one. If you want to do a 2x2 box, you could do a 2x2 box on this one. We will get the practice with this. We will. But ultimately, your final answer should be something like 2x squared minus 5x minus 3 if you multiplied them out correctly. With either foil or a 2x2 box or what have you. Then I get to f divided by g of x, where I literally go 2x plus 1 divided by x minus 3. Now, believe it or not, there's nothing you can do to simplify this. There is nothing for this particular problem that you can do to simplify this. Ms. Markey, how do you know? How do you know you can't? Well, you're going to see this on number 3. You're going to see this on number 3. But you can't factor any of this. And something on top would only cancel out with something on bottom if they matched exactly. Ms. Markey, x and x, yeah, technically you can't do that. Technically you can't do x and x because they're stuck inside of parentheses. And the only way that this 2x plus 1 is going to cancel out is if there was another 2x plus 1 on the bottom. This is all you can do to the problem. That's all you can do to the problem. But now let's look at number 2. Now, number 2 redefines everything. Number 2 redefines everything. Number 2 says, okay, f of x is this, g of x is this. Absolutely yes. Okay. Now there's a few things we can do here. This is where it gets a little dicey. First, I got to add them together. They're not like terms. They are not like terms. There is technically one thing you can do here, but it's not really necessary per se. What did you guys learn about? Hold on, let me give you an example. What did you? I don't know when you learned this. You learned this a long time ago. Long time ago. But give me a single digit number. 4? I'll go with 4. I don't know when you learned how to do this, but watch this. Were you ever taught to do something like this? I don't know what grade level it was. I have no idea what grade level it was. Does that look at all familiar to, let's say, like late elementary school, middle school? 6th grade, something like that? It's a similar concept. It's a very similar concept to what we just did. Technically, they don't like it if you leave it like this, because you're like, hey, you can combine stuff. But how? They're not like terms. You can't just do 4 plus 1/4 and just, 4.25. Yeah, you could do 4.25. But if they just want like an improper fraction, you would do something like this, where you would find a common denominator and kind of do stuff. So it's stuff that, you know, you haven't seen in like 5-6 years, you know? Technically, I guess you could leave it like that, but another way of doing it is like 8x to the 4th over x squared plus 1 over x squared, and then getting this junk right here, which I'm not really a huge fan of. I'm really not a huge fan of that. So I'm going to say, if you left it like that, I'm perfectly fine. I'm actually pretty fine with that. Because I'm not going to be expecting you guys to be like, oh, I got to use that trick that I learned in 6th grade in order to finish out this problem. Not really a huge fan of that. Of x, it's just literally this. Yeah, it's just literally that. Now, multiplying and dividing is a different story. Multiplying and dividing is a much different story in regards to simplifying this stuff. If I were to multiply this junk together, this should be 8x squared times 1 over x squared. Now this we can simplify in a much nicer way. What have you guys been taught in regards to multiplying? Let me repeat, multiplying fractions. What have you been taught about how to multiply fractions? I did not teach you this. I don't even think you learned this really in Algebra 1. You may have practiced it in Algebra 1. You got to multiply top times top, bottom times bottom. Anyone know what grade level that might have been? 7th or 8th grade? I don't know. I have no idea when you learned it. It's weird. I don't know when all this stuff actually happens, but check this out. 8x squared, you put it over 1. When you multiply them top times top, bottom times bottom, you can simplify this. This becomes 8. It just becomes an 8. Because x squared divided by x squared, they just cancel each other out. Or x squared divided by x squared should give you x to the 0 power, which what is x to the 0 power? Just 1. 8 times 1. That's all it does. But now you got to dig deep for the next one. You got to dig deep into your mathematical bag of tricks for the next one. F divided by g of x equals 8x squared divided by 1 over x squared. Look at what I have written on the board. And you tell me, what have you been taught about dividing fractions? Because I didn't teach you. Is there a rule for dividing fractions? Different people have learned it different ways. I have heard people refer to it as KCF. What does that mean? Keep, change, flip. Keep, change to multiplication, flip. Yes. 6th grade? Like I said, I didn't teach you. Keep, change, flip when you divide fractions. This really should be, what are you supposed to do? Say again? Yes. What did you do to the exponents? You added them. Yes. This really should be 8x to the 4th. I'm going to say something very declarative right now that I need you to listen. Very declarative in referring to exponents. Exponents will change if you are multiplying or dividing variables together. Let me repeat that. Exponents will change if you are multiplying or dividing variables. Exponents will not change if you are adding or subtracting. Multiplying, dividing is the name of the game. If you are multiplying or dividing variables, exponents are going to change. If you are adding or subtracting, they are not. Finally, number 3, before I introduce to you the 4th operation, this following and g of x equal to the following. Tell me something about those two equations. What are they? What kind of equation are they? Oh no, everyone forgot. What kind of equations are they? Guess just random mathematical equations. Not anything that we've seen since September. The longer the silence goes on, the more awkward it becomes for you guys. Well, I heard a couple different things. Technically, only f of x is a trinomial. Say it one more time. They're quadratics. Yeah. Now, technically, just for the sake of argument, yes, the first one is technically a trinomial, and the second one is a binomial, but they're both quadratics. They're also factorable. But we'll get into that later. First of all, add them together. Well, if I'm going to add them together, Mr. Markey, I guess I have to combine like terms. Yeah, you do. Terms. X squared plus x squared should give you 2x squared plus 7x plus 3 because it's 12 plus negative 9. Remember, when you are adding variables, the exponents don't change. X squared plus x squared, well, it remains the same exponent, but now it's a 2x squared. When you subtract them, now keep in mind that you are subtracting the second one in this instance, so it is going to be a minus x squared plus 9. Yes, indeed, the x squareds cancel, leaving you with 7x plus 21. But now for the big ones. First, I got to multiply this junk together. Oh no, if only there was an easy way to multiply this junk together. If only there was a nice organized kind of way to multiply this trinomial. There is a nice and easy way to do it. And the nice and easy way to do it is what you're looking at right now. So, if I'm going to do this junk here, this is going to get me an x to the fourth, a 7x cubed, a 12x squared, a negative 9x squared, a negative 6, and a negative 108. Oh my goodness gracious. Yeah, I know. But that's what that stuff does. Again, like I said, the easiest way to go about it for multiplying this junk out might just be this 2x3 box. Foil's not going to work. Foil's not going to help you. But now I got to combine like terms. X to the fourth plus 7x cubed plus 3x squared minus 63x minus 108. This, I'll zoom out. This is the stuff that we have to know how to do. This is the stuff that we're going to be seeing at various points when trying to solve this stuff out. These are the skills that we need to have combined with our exponent properties to be able to handle what I'm going to be dishing out at you during this chapter. And finally, there comes division. When I divide these two terms in the order that they tell me, unfortunately for you, I'm not going to leave it like that. Because both the top and the bottom of that fraction is factorable. Both the top and bottom of that fraction is factorable. In fact, the top of the fraction becomes x plus 3, x plus 4 when you factor it correctly. And the bottom of that fraction becomes x plus 3, x minus 3. The only way you're allowed, only time anything can happen and change in the way that we kind of want them to is when there is multiplication, division separating them. The x plus 3's technically cancel each other out, leaving you with this x plus 4 over x minus 3, which is all that we can do to the problem. That's all that we can do. It's really messed up. To wrap up today, I want to introduce to you the fifth operation. I said there were 5 operations. The fifth operation, putting this directly into my notes, the fifth operation is known as composition. The fifth operation is known as composition. You've always had addition, subtraction, multiplication, division. Now here's composition. I'm going to give you the verbal definition in my own words, and then I'm going to show you how it works. A composition is plugging one equation into another. It is plugging one equation into another. It is literally taking one equation and substituting it inside of the other equation. Let me show you what the notation looks like. So here's an example. Problem that I did today. The original problem that I did today, which was f of x equals 2x squared and g of x equals x plus 1. I'll move that up. Here we go. Here's what the composition function does. On there. Look at that notation. This is something that you may have never seen before. But look at this. I'm going to erase this red mark in a moment. I'm going to erase that in a moment. But look at what their g of x is doing. Look where it is. It is literally inside of the other function. We're taking that g of x and we are putting it inside of the f of x function. We are plugging it into the f of x function. We are substituting it in for the variable in the f of x function. There is another way of looking at this notation, and you'll see that notation on this particular worksheet. How do you kind of want to read that? How do you want to read that notation? Let's see. Read it. Say again. How do I read that? Or I'm sorry. How do you want to read that? You want to read a fog. Do you want to read a fog? You don't. You read it f of g of x. That's how you're supposed to read it. You're supposed to read f of g of x in the order that it is written. People even do it like this, where it's like, you could even reverse them like this, and it would give you a different answer. And people are like, oh, goth. Yes, I know it reads goth, but you're supposed to read that g of f of x. That's how you're supposed to read it in the order that the letters are written. It's kind of silly. It's kind of messed up. What it does is this. If I'm going to do f of g of x, tell me, what does f of x do for my example? What's f of x programmed to do right now? what equation did I set equal to f of x? 2x squared. That's what it's supposed to. 2x squared. It's supposed to square the x, then multiply it by 2. That's what f of x is at the moment. It's supposed to square the input and multiply it by 2. Check this out. Two parentheses, blank temporarily. What goes into that blank, let me get the red marker out. What goes into that blank, is the g of x function. Whatever the g of x is. In this case, in this example, the g of x is x plus 1. But I am taking this x plus 1 and substituting it into the f of x function. That is what it's supposed to do. This is weird life. That is okay. We are going to get used to this, and there is a reason why we're doing this stuff. It is going to relate directly to what we've been doing. This is the composition function. So in that blank, I am going to put the g of x function. Well, what is g of x? What is g of x programmed to do? Programmed to do at the moment. So if it's programmed to do that at the moment, then I put that inside. You are living one equation inside of another equation. It is something that you may have never done before. Another. Now I got to simplify this junk. If I were to simplify this junk, it would become the following. Remember what I said. Are you allowed to distribute that exponent? Nope. I put it in big capital letters. What operation's in the middle? Yeah, you can't do it with addition, subtraction. You can only distribute it with multiplication, division. If I multiply this junk out, it becomes the following. If I distribute that 2, which is, I get that as my composition function. It's really messed up. This is a means to an end. This is a means to an end. We need to learn how to do this composition function in order to move with this chapter. And that is what we are going to do. On Thursday, we are going to get more practice with composition functions. We are going to see, remind me, what did I tell you was happening Monday? Benchmarks. And then Wednesday, we'll continue working on whatever we need to work on. And then we'll be on break. Remember, I don't think that the winter storm is actually going to happen the way that we want it to. But even if it did, I'd still be teaching. Connection is unstable. Oh, so am I. And I'm a sign off. Good night, everyone.